The SUNY College of Environmental Science and Forestry, founded in 1911, is now the only institution of higher learning in the United States dedicated solely to the study of natural resources and the environment.
And welcome to this edition of Improve Your World with SUNY-ESF. I'm Don Torrance, and on today's program we're going to do a little bit of golfing, we'll take a balloon ride, and we'll also talk with researchers looking at the influence of vegetation on temperature and air quality in commercial versus residential neighborhoods. But we will begin today on the golf course. You might think that greening up a golf course would be a bit redundant, but looks can be deceiving. Sometimes green color doesn't mean environmentally friendly green, but that is beginning to change.
The typical golf course that relies on pesticides, synthetic fertilizers, and irrigation systems to maintain a beautiful green carpet is giving way to new courses that rely on a more organic approach. Chris Cartini and Barry Jordan are part of an array of ESF alumni who, in addition to some current students and faculty members, do work that touches on the movement to make golf a more environmentally friendly game.
The USGA is golf's governing body, and just recently at this past US Open, which was hosted by Pebble Beach Golf Links in California, they showcased the golf course as a sustainable use facility. Very low inputs with water, fertilizer, and pesticides. The course looked different, for sure. Just by viewing on TV, you can notice that the course was under considerable stress. However, the champion, during his interview afterwards, said that the course played absolutely beautifully and that it was fair and well set up.
The thing that you have to be careful about is making sure that the golf course is still playable. But you can do that by really scrutinizing where most golfers are going to hit their shots. Around tees are good areas for naturalization, and certain places where you want more safety, you can put natural areas in because it's areas where you don't want people to hit.
The techniques that we've implemented here at Beaver Meadows is trying to reduce our highly maintained areas. And so what we've done, and you can see behind us, is implemented areas where we can eliminate high-intensity mowing operations and let the grass get taller. Obviously, that feeds into the habitat preservation aspect, as well as reduced labor costs, reduced fuel costs, and then to help save on the budget.
No matter what aspect of landscape architecture you're involved in, trying to use what's there, whether it's a development for housing, or you're trying to, tread as lightly as you can on the landscape. But I think it's a little bit more complicated just because of the nuances of golf, the variety of players that you have to design for that hit the ball, sideways, some of them. And so you really have to balance the aspects of the game with, what's out there. Whereas if you went in, and I think that's what sometimes people are doing, is they're clearing everything and they're making everything playable, but you end up rewarding people for a bad shot, whereas if you tighten things up a little bit, then you can reward people for a good shot and make them focus more on where they're trying to hit the ball.
Some of the other disadvantages would be the lowering of quality turf in some areas that affects playability to golfers. I think it's a balancing act, though. We want to obviously do our best to safeguard the environment and be stewards, and our goal of sustainability. But at the same time, this is a golf course, and our main priority is providing the best quality surfaces we can. Golfers do have high expectations, of course, and we try to deliver the very best product that we can every day.
The perfectly green, manicured golf course is something that has evolved over time and over here. Now there's an effort to go back to the original idea.
I think what you can really look at is going all the way back to a course like St. Andrews in Scotland, which never really went in that direction. There, the roughs have always been let grow. There, they never really did irrigate all the fairways, all the roughs. They do use irrigation there on the greens, but it's always been a much wilder golf course.
There's a different philosophy. I mean, one, the landscape over there is where they're built. A lot of the original courses are sandy soils, naturally grassed areas, and so they were taking sort of these, seaside landscapes and using them and cutting the turf for the golf course paths, and then it was more naturalized on the edges. Here, it became more and more manicured over the years, and so there's been this whole movement to get back to, more of the original, aspects of design.
In the last 10 years or so, we've seen an awful lot more growth of the idea of using golf courses as actually an opportunity for not just what happens on the golf course, but areas surrounding them to be buffers, particularly for stormwater runoff. The rainwater that runs off of hard surfaces, streets, roads, roofs, as well as off the fairways and greens that have a lot of pesticides that may be applied, the fertilizers that may be applied, if they can be then funneled through created wetlands, rain gardens, if you will, on a massive scale, then there's a real opportunity to cleanse that water of extra nutrients, of impurities, of the pesticides, and before it's returned to a natural setting like a creek or a lake or to the ocean, an awful lot of filtration can occur in a place like a golf course.
Plus, new technology can help in the earliest design stage of building a new golf course or redesigning an old one.
Now with the technology, you can do a lot of mapping that they used to have to do by hand before, so you can find all the ecologically sensitive areas, kind of flag those out, and then try and fit the golf course around those or use those as hazards. And protect corridors, wildlife corridors, and things that will enhance. It will have some benefit to the environment. And a lot of my work is redesign, so I can go into a course and reconfigure things and actually end up with less maintained turf.
Golf courses are also becoming popular in difficult places to build anything, industrial brownfields.
That's a new place that we've begun to see substantial new opportunities for golf courses, particularly in urban areas. Because the land is so expensive in many urban areas, it's been very difficult for new golf courses to be built there. But we've seen some examples in and around the New York City area, some fantastic examples in the Chicago area, and even in more rural places. Jack Nicklaus designed and had a golf course built in some of the most contaminated locations that you can imagine, in copper tailings and with arsenic poisoning and all kinds of things. Outside the Anaconda mine in Butte, Montana.
The attributes of a good golf course complement the effort to protect the environment from the contamination that's in the brownfield.
The golf course can be built on top of a fairly contaminated site. And in many cases, particularly with an example like that I just provided in Butte, Montana, it needed to have topsoil brought in anyway. That topsoil then can provide some kind of a cap, along with liners and so on, to prevent the rainwater and stormwater from leaching down through and moving into the groundwater system. In addition, in many cases where we're trying to cap contaminated sites like that, they don't want to see trees growing. The roots from trees can, in many cases, and I'm not quite sure how well this has been designated or demonstrated scientifically, but the fear is the trees will penetrate through the cap layer and allow water to move in and through those contaminated sediments underneath. Golf courses, while we often in the United States like to grow trees all over them, don't need that. If you look at their Scottish precedents, there's not a tree anywhere to be found at St. Andrews, and many other courses like that. And in the last 10 or 15 years, links-style courses like that have become very popular in the United States. The course that the most recent PGA championship was played on in Wisconsin along the edge of Lake Michigan is a links course. There's few, if any, trees in most of that design in Wisconsin. And such is the case with the course that Nicholas built in Montana.
The golf course provides a viable use for the property that isn't too intensive.
One of the things that's feared if you redevelop a brownfield site with residential uses, for instance, that you've got little kids that are out with their shovels digging around in the soil. Golf course, while it's not exactly a situation where no one's ever going to dig into the soil, we've seen everybody take a divot now and then, it's still a situation where the potential for human use coming in contact with the contaminated soils in any serious way is pretty minimal. We're not trying to push large amounts of dirt around after construction is complete, and it allows you to build enough of a buffer area of new soil that might be brought in that sort of a situation. The other thing is when we're dealing with some types of brownfields, in many cases the actual construction of the golf course can help in remediating what types of contaminants might be there through phytoremediation. The planting of the appropriate types of plants can help to pull the contaminants out of the soil or leave the contaminants in locations where they're not going to be problems.
And the new environmentally friendly golf course also provides an added benefit.
Golf courses, particularly if the design incorporates the right types of vegetation, are wonderful wildlife habitat, particularly for songbirds, a lot of birds that may nest on the ground. In the lynx type environment, it's nearly ideal for that type of a nesting habitat. There's a lot of different wildlife that can live in an urban area that would find a golf course highly advantageous, particularly for nesting and rearing of young and so on.
And it doesn't hurt that creating a more natural golf course can also result in substantial savings in maintenance and supplies. Coming up next, we go up, up, and away.
One of the two most commonly used tools is the hammer. Hammers are used to drive nails, brads, anchors, and assorted other fasteners into a variety of materials like wood, gypsum, wallboard, and masonry. The most common is the claw hammer. Pounding them in on one side and pulling them out on the other. The claw hammer can also be used as a pry bar. Choose a size and style that's comfortable and easy to handle. You don't want it slipping out of your hand. Ball peen hammers are used for shaping metals and closing rivets. It's not a safe substitute for driving nails. Sledgehammers are used for larger jobs, such as driving fence posts or breaking up concrete. A joiner's mallet, an all-wood hammer, usually made of beech, is used for tapping wood joints together or driving chisels. Hammers produce flying debris, so you should always wear protective clothing and safety glasses.
But a group of students in environmental resources engineering overcame adversity to successfully launch a weather balloon that lifted 17 miles above the earth and traveled to Poughkeepsie, New York, before coming down.
It was actually a semester-long project. They've been tackling this for a while. And as you can see from their faces, they're pretty happy campers right now.
It's a big adrenaline rush, definitely.
I mean, we've been working on this thing for a couple months now, ever since the beginning of the semester. And so it's so exciting just to see it go up, and hopefully we'll be able to retrieve some images.
The class is called Remote Sensing, and it teaches undergraduate students the techniques behind satellite image analysis.
A little more, Julie.
Don't drag it on the table now. They get really excited when they can actually replicate things that you're teaching inside the class.
We were actually completely set to go inside, and we were starting to walk outside, and as we turned, we saw it pop, and so it was a little disappointing. But
A very unfortunate event, but you know, like that's part of the engineering process. Is, you know, you try it once, it doesn't work. You have backup plans, which we did, and second one went up, first one popped. So, but it went up, so we're hoping for the best.
The major challenge we had was the wind, and the original weather balloon we had actually burst on the ground, so it never took off. But we were lucky we had a backup plan. We used a little bit of a smaller weather balloon, and within an hour we fixed the glitch and we were up in the air.
it gives you a really good hands-on experience just in general design and implementation of engineering skills. And it's also, I mean, it's just something really fun, and it's really nice to be able to say, you know, like see something that you actually did, like come to life.
We have a helium balloon, a typical weather balloon. Then we have two parachutes connected to each other, a small one that will hopefully pull out a much larger parachute to slow the descent. And then we have the styrofoam box that contains all the electronics. The electronics are two digital cameras. One is taking videos, the other one is taking still pictures every 15 seconds or so. And we also have a cell phone that we'll be using for GPS tracking purposes. So we can go and we can retrieve the payload. We expect to go somewhere between 90 and 110,000 feet. Hopefully at that altitude we'll be able to see the curvature of the Earth, at least in a small scale.
The first time it's actually been done where we're going to get to retrieve the photos as everything goes to plan. So we're hoping for the best.
And based on some weather predictions, we are hoping somewhere maybe 50, 60 miles south of Albany right now.
Now, as you can see, the exercise provided the students with some stunning photographs. They also had a video camera attached to the payload, but the winds at that altitude bounced it around so much it wouldn't be very pleasant for you to watch. Now, when we come back down to Earth, we're going to take a look at a study of vegetation and its effects on temperature and air quality. We'll be right back.
One of the two most commonly used tools is a screwdriver. Screwdrivers are made to drive specific types and sizes of screws. This is the flathead screwdriver. The flat blade varies in size, which is selected based on the size of the screw slot. The closer the match, the easier it is to tighten the screw. The Phillips head screwdriver is designed to be used with screws with an X-shaped slot. Again, the closer the match, the easier it is to tighten the screw. Which screw to use? The Phillips head screw is designed for the application of extra torque, so it provides a tighter fit. Use it when tightness is critical. The Allen key or Allen wrench, a hexagon-shaped screwdriver, is often used to put together furniture. It's often L-shaped. Power screwdrivers come in two forms. One is a socket driver approach that can be used with power drills. Many drills have special speed settings for driving screws. The second is a standalone coreless electric or power screwdriver.
A study is underway geared toward enhancing the quality of urban life, and part of that study involves air temperature measurements.
This project is going to use 11 weather stations at different locations where the tree cover and the buildings are different. For example, we want to put one in downtown Syracuse with our large buildings, and then we'll have others that are in suburban locations, and one, for example, in a small forest, which is at the experiment station. They call it the Forestry Experiment Station on Lafayette Road. The purpose is to find the temperature difference pattern across the city and how trees and buildings influence the temperature difference. And then from our temperature differences, we will be doing computer work to make prediction equations of those temperatures. The next step then will be to map the temperature differences across the city for different weather conditions, general weather conditions, and to then make predictions of how the tree cover affects the temperatures. Then we will be able to change in the computer the tree cover and find out what happens when we change tree cover in the city. Well, this is a weather station. So this is one of the 11 stations that we'll have around the city of Syracuse. This is a standard package that comes from a company that makes relatively inexpensive instrumentation. It's called an integrated sensor suite. This one package measures, beginning at the top, the wind direction with what's called a wind vane, and then we have these cups spin around and measure the wind speed. That's an instrument that's called an anemometer. Then we have this bucket-looking thing which measures the rainfall. Here we have a small sensor to measure the solar radiation. So we're actually, at this point, measuring the solar radiation that's at this location. The electronics are inside this box, and there's a small solar panel here that operates the electronics. This is the antenna, so that signals are sent to a small box that most of these weather stations will have, like this, that's inside here, and it will be recording the observations. So it'll be continuously making measurements and then recording the observations. We happen to have that small black box in our office, which is located just over here at this point. This is inside of here. This is a radiation shield, it's called. That is, it blocks the sun from the sensors that measure the temperature and humidity. We have a little bit larger solar panel right here, and this solar panel runs a small fan. It operates a small fan, and there are batteries that make that fan run at night when there's no sun. The solar panel charges the battery and makes that fan go around. We could take a closer look, if you want, at one of these units that has been removed from another station, and it's right here. So we see here the solar system here that operates a fan, and the fan is right here, and we'll take the fan out here. We can remove this fan carefully, and then we see that inside there is the temperature and humidity sensor inside this small screened unit here. That's where the temperature and humidity sensor are located, and there is a lot of shielding around them. Actually, it's sort of a pipe with air spaces around the temperature and humidity sensor to keep the sun away from it. And so if we put this back, this is the way the whole system fits together. And then we can put the fan back, and this is the way the fan operates to pull air through a small screen down here, and all of these plates around here keep the sun away from the center and pull the air up and out. So this would fit normally just underneath of the weather station. The other item that might be of interest, if we can manage to take this off, we can see that this is the bucket that the rain goes in, and there's a small hole down here in the bottom. The rain falls in here, goes down through that hole, lands in one of these buckets. Here we have really small, these really are small buckets, and the rain comes and lands in this one. When that gets filled up, it can tip over like that. And so we call this a tipping bucket rain gauge. It goes back and forth as the rain falls, fills one bucket, and then that bucket gets dumped out and the next one gets filled. And there's a timing, of course, so that we can know how many tips there are per unit of time in order to accumulate the rate and the total amount of rainfall. One of the reasons that we got this kind of a unit is that it's fairly inexpensive. This actually is within the range for a hobbyist person who's really interested in weather and wants to make measurements at his house. People do that. There are a number of them in Syracuse who do that. And so it's affordable in the range of about $1,000 or somewhere in that a number of dollars, so that you can afford to do that. We have tested these and found that they are fairly durable. They will last for a reasonable number of years, actually, operating with little attention. And if something does break, the cost to replace parts is fairly low, so that although this is not the most accurate of all systems for measuring the weather, it's reasonable for our research purposes and inexpensive. We have also found that it's surprisingly less often that vandalism occurs in a city than we might expect, fortunately. People do seem to recognize that this is a useful device, and they usually let them alone and don't pick them up and run off with them or something else. We're basing our methods on a study that we did recently in Baltimore. We also have collaborated in a study in San Juan, Puerto Rico, where sensors were placed around the city to make temperature measurements and then predict the effects of the tree cover on the temperature in that city as well. The trees might influence the temperatures of houses in a negative way. They can also have a positive influence because they reduce the wind speed, for example. And trees can be placed around houses so that there's not much reduction in the solar energy coming into the house if they're placed in accordance with the path of the sun across the sky.
Syracuse is one of 16 locations making up the Urban Long-Term Research Area Program. The U.S. Forest Service and the National Science Foundations are partners in that program. Well, that's all for this edition of Improve Your World with SUNY-ESF. I'm Don Torrance, and I hope you'll join us the next time.